Okay, so in the last video, we talked about how to find our p, our factors of p, which is our constant term, and our factors of q, our leading coefficient, and how to use those factors to create ourselves a list of possible zeros. Today, I want to talk about how to use that list to actually find the true zeros of a function. So the idea here is if you look at this function I've given you up at the top, we have f of x equals 2x to the third plus 3x squared minus 18x plus 8. Well, if we wanted to find the zeros of that, we could try and factor it, because that's how we did it in 3.5. But the problem with that is there's 4 terms, so the only method we'd have for factoring is grouping, and this does not look like something that's going to work factoring by grouping. So if we can't factor by grouping, then without the rational zero test, we'd be at a loss. But because we do have the rational zero test, I've gone ahead and done the P's and Q's because we already did a video on that and I don't want to take time in this video going over it again. So right down here, we've got our list, and remember this list represents our list of possible rational zeros, right? Obviously not all of these are zeros of this function because this is a degree 3. It's got a x to the third, and so certainly all of those, what we've got 1, 2, 3, 4, 5 of them, positive and negative versions, so all 10 of those on our list can't possibly be answers. The ones that are answers, though, those would be factors of this function, right? Think about like if it ends up that x equals 1 was an answer. If x equals 1, if 1 is one of our zeros, then that would imply that before that we had had a factor of x minus 1 that we had set equal to 0 to solve out, right? When we talk about factors, the word factor is meaning that it divides evenly, or another way of saying divides into something evenly would be you have a remainder of 0. And we have just learned how to do division with polynomials and how to check for remainders. So effectively, what we're going to do here, and hopefully this is able to make sense in a short video like this, but we're going to take our function of 2x to the third plus 3x squared minus 18x plus 8, and we're going to create a synthetic division problem using those numbers. So, So, we draw that L shape, right? And we use the coefficients. We start with our x to the third coefficient, which is 2. Then we look for our x squared coefficient, which is 3. Then we'd take our x to the first coefficient, which is negative 18. And then we would take our constant, which is 8. That would be our setup for our synthetic. We can choose any one of these 10 possible zeros that we have from our P over Q test that we did. And we can test any of them, and if plugging any of those in gives us a remainder of 0, well then it's one of our answers. So for example, let's see if 1 does happen to work, right? Positive 1 is certainly one of the numbers that we have here, so let's say I want to try positive 1. Well, if I want to try positive 1, let's do synthetic with that. So the 2 would drop all the way down. 2 times 1 is 2. 3 plus 2 is 5. 5 times 1 is 5. Negative 18 plus 5 is negative 13. Negative 13 times 1 is negative 13. That's unfortunate. 8 plus negative 13 gives us negative 5 as a remainder. It does not give us 0. Okay, so 1 didn't work. That's too bad. But maybe negative 1 would work, right? Maybe negative 1 is actually the secret, so we should just try negative 1 instead. I guess I didn't have to erase the drop down arrow because we're always starting with that. 2 times negative 1 is negative 2. 3 minus 2 is 1. 1 times negative 1 is negative 1. Negative 18 plus negative 1 is negative 19. Negative 19 times negative 1 is positive 19. That also doesn't give us 0, so that's a bummer. That means neither of the ones worked out. Now, as you can see, this could take a while depending on how long your list is. Here we only have a list of 10, thankfully, so even if we had the worst of luck and it turned out the last one we picked actually worked out, at least we've only had to test it 10 times. But you could have an even longer list that could take a very long time. The other way to figure out what would work is, remember, we're talking about zeros. Zeros mean the same thing as x-intercepts, means the same thing as roots. If you graphed a function out, you would be able to look and see where that graph crosses the x-axis at. And then you'd have an idea of what numbers should actually work, and then you could test more just to prove that that's actually true. But if you don't have the ability to graph, you just have to keep testing out. Now, to make this a little bit quicker, I'm going to recommend we try 2. If we try positive 2 here, then 2 drops all the way down. 2 times 2 is 4. 3 plus 4 is 7. 7 times 2 is 14. Negative 18 plus 14 is negative 4. Negative 4 times 2 is negative 8, and that does give us 0. Okay, so I kind of gave you which one works. So, if you find, or when you find the one that works, first off, recognize that is one of your answers. So you should write that off to the side somewhere so that you don't forget x equals 2 is one of the zeros of this function. But we have more to find. Now what you could do is you could continue doing synthetic. You could keep testing the other numbers until you have found all 3. Or what you can do is take a look at the answer you just got here. Remember, we started with 2x to the third. So if we did synthetic, then that would mean this 2 here would be an x squared coefficient. And this 7 would be an x coefficient. And then this 4, this negative 4, is a constant. That's a quadratic. So you don't need to do more testing unless you want to, because you could either A, try and factor this if it's possible, or B, you could always solve this by the quadratic formula. So understand, while you can go back and test for the others, once you have done enough synthetic testing to get down to a quadratic answer, you never have to do more testing because you should be able to solve the quadratic immediately. In this case, we can factor this because our a value of 2 times our c value of negative 4 would give us negative 8, and our b value of 7 would mean we're looking for 2 numbers that multiply to negative 8 but add to 7. Well, that would be 8 and negative 1. Do make sure you recognize our a value is different than 1, so you can't go straight to factors of x plus 8 and x minus 1. You need to either split this up into factoring by grouping, or if you are going to go straight there, then you need to do the extra step of dividing both of these terms by that a value. It's 2 different options on how you want to factor that. It's up to you depending on how you've learned it in the past. It doesn't matter, you should get the same answer at the end. In this case, with this shortcut way, 8 divided by 2 gives me 4, so x plus 4 is a factor. Since 1 does not divide by 2 evenly, I take that 2 and move it in front of the x as a coefficient, and 2x minus 1 would be my other factor. Then, I can set each of these equal to 0 and solve out, and we get x equals negative 4, and x equals positive 1/2, and we also don't want to forget that we figured out x equals 2 from our synthetic division problem up above. And that would be your full answer as to what the zeros are for this function. Obviously, depending on each function that you are given, it can take a while to test if you're not sure where to go, and these do take a bit to solve, so you may want to watch this video again, or at least watch parts of it again to make sure you understand the full process. But overall, we are finding the factors of p and q, and using that to make our list of possible rational zeros, setting up a synthetic division problem where the coefficients in the synthetic division are the same coefficients from the original function, and then you are just testing random numbers from your possible rational zero list until you find one that specifically gives you a remainder of 0. Any other remainder, it doesn't work. You keep doing that until eventually you have done enough synthetic division that you get down to a quadratic, and then solve that quadratic out either through factoring if possible or through the quadratic formula if necessary. And then you have your answer.